Okay, so we just went over those 4 graphing problems that you had for homework. The last one was extra credit. We're going to go ahead and get into our notes for today. Today we're going to talk about application of this, okay, which is velocity. And this is kind of where we see some overlap between calculus and physics. Have you guys started talking about this in physics yet? You already have? Okay, so again, I have told you this before, I'll tell you again, I don't care if you do it the calculus way or the physics way, but I can only give you partial credit if you do it the calculus way, because the physics way for me was, how many years ago was that? 13 years ago, and I don't remember it, okay? So, you can do it, if it's right, it's great, but if it's wrong, I can't give you partial credit because I don't know what you're doing. So, let's talk about our formulas. An object traveling in a straight line with position f of t at time t has this velocity. Now folks, what does that formula look like to you? Yeah, isn't that the same formula we were using to find slope? Except for it was f of x minus f of a all over x minus a, correct? So now, this just has different variables in it to look like f of t. Okay? Same thing. You'll notice we're finding the limit. Velocity is a speed. Speed is a rate of change. Rate of change is a slope. So we're finding the exact same thing. Except for this time, there's going to be a situation that goes with it. And I need to remind you of these h of t formulas. We use negative 4.9 with which unit? Meters. We use negative 16 with which unit? Feet. Okay. Remember, these things are quadratic, which means they are parabola shaped, because when you throw something up into the air, it makes a parabola. It goes up, then it comes back down. Again, same formula, just different variables. So basically today, we are just going to do a bunch of practice problems on these applications. I'm going to give you a situation, we're going to write the formula, we're going to find the limit, and that's going to tell you exactly how fast that object is going at a specific instance in time. Okay, so if I do throw markers at those freshmen like you told me to, after it leaves 1 second after it leaves my hands, how fast is it going? That's what it'll be telling me. Okay. Are we good? I do have a follow-up question though. If the object is on the ground, how fast is it going? 0. Remember, when it hits the ground, it has no more speed, right? No more velocity. Okay. So let's take a look here. And again, you don't need to copy these word problems down. Remember, I post in the classroom, so you'll have them there to look back at if you need to. Galileo, you guys know who Galileo is? Who's Galileo? You guys always say yes, and then you never really know how to. Astronomer, physicist, brainiac. Okay? Real old, real dead. But a lot of what he did affects what you do in your math and science classes today. Alright, Galileo is reported to have dropped 2 iron balls from an upper balcony of the Leaning Tower of Pisa. You guys know what that is, right? Okay. Approximately 49 meters above the ground. If we neglect air resistance, determine how fast the iron balls would have been traveling after 2 seconds in flight. Well, if I'm asking you how fast, that's a speed, right? Am I asking you for a speed, that's a rate of change? Asking you for a rate of change, that's a slope. So I'm asking you to find a slope, we're going to do a limit. You see that train of thought, right? Okay, so I'm going to be finding a limit as t approaches what? At what instance in time am I looking at? 2 seconds. Now, in order for me to fill in this formula, I got to write a function. Am I talking meters or feet here? Meters. So this is going to be h of t is equal to negative 4.9 t squared. Do these objects have an initial velocity? Were they dropped or thrown? Dropped. So they do not have initial velocity. But what is their initial height? 49. So there's my function. I also will need to know at what point I have for time of 2. So at time 2, how high will those objects be off the ground? Say again. 29.4, she says. Are we all okay with that? Okay. So now I'm ready to find my limit and find my answer. The limit, as t approaches 2, of f of t. Now f of t is the same as h of t. Do you guys want me to change this to an f? Be consistent or leave it as an h, you don't really care. Doesn't really matter. Okay, so my function is negative 4.9 t squared plus 49 minus the specific height of those objects. Thank you, sir. Which is what? 29 minus 29.4 all over t minus a. In this case, is 2. How are we doing with the setup? So I want to reiterate this to you. And to Joey and Dylan, okay? This is f of x minus f of a all over x minus a. Same thing we've been doing, correct? Okay. Let's get rid of those. And let's combine our like terms. What do you get up there in your numerators? 19.6? So I cannot just plug in that 2 right now as it stands. The only way you know how to fix this right now is factoring. Good news, I know what I want to cancel out. I want the t minus 2 to cancel out, don't I? Bad news, that numerator doesn't look like anything like what I want to factor. Fair enough? Can you think of anything that might work to help me factor this? I will ask you, what is the leading coefficient in your denominator? What's the leading coefficient in your denominator? The coefficient is the number in front. There's a 1 in front of there, right? So if I even want to begin to factor this thing, I got to get a 1 out front of that t squared. That's what we're going to do. We're going to take out a negative 4.9. And we're going to cross our fingers and see what happens. So everybody good with that being a t squared there, right? Now if I'm taking it out, aren't I dividing by it? So I need to know what 19.6 divided by negative 4.9 is. 4. And it's negative 4, isn't it? So that when I distribute this in here, it becomes positive. And you'll notice that works out pretty nicely for us, doesn't it? Folks, it will always work out nicely like this, or I didn't make the problem right. Fair enough? Okay. That's the difference between math and science. The math has to work out really nice and neat. The science can have crazy decimals all over the place. Okay? Okay, so now what am I going to do? Yep, take the 2, put it in there. That'll be a 4 times negative 4.9. And this is just a coincidence that it's this number. What is it? Should be negative, right, folks? What's the units on this? Meters per second. Now, if it's negative, that means it has direction. That means velocity, right? I don't remember whether or not the original said velocity or speed. It just says how fast. Does everybody see that? So it would be okay if you just told me 19.6. Everybody understand the difference between velocity and speed, right? Any questions on this before we move on? Do another one? Okay. Suppose a stone was thrown downward from a bridge 20 meters above a river. If the initial velocity is 4 meters per second, determine the speed of the stone after 2 seconds. And this is kind of a really, I don't want to say negative, but not really great to think of example. Do you guys ever remember seeing the news coverage when those teenage boys in Michigan were dropping things off the bridge and they actually killed somebody? Okay, so that's kind of the situation that's happening here. We're going to calculate how fast would that object actually be going after so many seconds. Okay, so here we go. Meters or feet? Meters. So when I make my h of t, I'm going to start with negative 4.9 t squared. Was their initial velocity? What was it? 4. Was that thing being thrown up or down? Which means it should be negative 4. And how about an initial height? 20. So here's my function. At what instance in time am I concerned with? 2. So I need to take 2 and plug it in and figure out how high that stone would have been after 2 seconds. What do you got? That number coming? Negative 27.2. Not negative 27.2. That's what I have. What'd you plug in? Oh yeah, you're supposed to plug in too. Grab your calculator. Negative 4.9 times 2 squared.
Oh, I had it.
From the first one. Okay. So are we everybody good with negative 7.6? Yes or no? Okay, so here we go. The limit as t approaches 2. Yep. Yep. Not really. No. My h of t minus my h of 2. So really this is going to be a plus. Is everybody all right with me turning that into a plus? Minus a minus? All over t minus 2. Combine your like terms. And you should get 27.6 over t minus 2. Everybody all right? Okay, so now we got a factor. And it's even a little bit uglier yet, because now I have a trinomial up top instead of a binomial, right? What are your thoughts here? What would you like to try and do? Besides quit and go home. Yes or no? I know what I want to cancel out, right guys? So why don't we start with that? I know I want a t minus 2, and now let's work our way backwards. If that's a t minus 2, what does this front term need to be to make this negative 4.9 t squared? T? Does everybody understand why I'm going to start with that? Yes? So we just took care of this term right here. Because this times this will make that. Now let's take care of this term. I've already got a 2 over here, right? So how are you going to figure out what's got to go in this spot right here? Divide this 27.6 by 2, which gives you 13.8. So folks, this number times this number has to give me this number, right? Should it be positive or negative if that's a positive 27.6? It should be negative. So we took care of the two ends. Now, here's where we cross our fingers and hope that this middle works out to be -4. Are you ready? Grab your calculator. What do I get right here? And that's t, right? What do I get right here? Positive? Does that make this -4t? Bingo. So we're A-okay on this factoring, right? It has to work out that way, otherwise something's wrong. All right, so what are we going to do next? I'm going to cancel it, and then I'm going to plug in 2. So when you plug in 2, what do you get? Now, does everybody see how it says speed? So the technical correct answer here is just 23.6 because speed does not have direction. Awesome. Okay, I think my next problem, I'm going to see how you guys do setting it up, and I'm only going to change one thing. Hold on 1 second. What am I doing? Okay, I want to do the same problem, and the only thing I'm going to change about it is now I'm throwing the ball up, or the stone up into the air instead of down. So tell me, if I get rid of all of this, and I want to rework this problem, what is the only thing that has to change? Now it's going to be a plus 14. Is everybody clear on that? So let's do it. So instead of that stone going straight down, it's going to go up into the air and then come back down. What is the first thing that you need to find? Not the limit. Plugging it in. What are you finding when you plug it in, guys? This number that you get over here when you plug it in, what is that? The height of the object at 2 seconds. So tell me, when I throw that thing up into the air, how high is it after 2 seconds? Should be 8.4. Now we're ready to set up the limit. The limit as t approaches 2 of h of t minus h of a, which in our case is 8.4, all over t minus 2. When you combine those like terms, what do you get? 11.6 all over t minus 2. And now here's where we're going to need to factor. I know I have a t minus 2 down here. So I'm going to start with a t minus 2 up there. What do I need to start this other factor with? Yep, negative 4.9t. That takes care of this term. Now this term is 11.6. So what are you going to do with that 11.6 and this 2 that I already have out here? Divide it. 5.8. Sounds good to me. Is that 5.8 positive or negative? It should be negative. so that those two negatives will end up giving me that positive 11.6. And now you're in business. I need to know what that velocity will be at 2 seconds. Actually, I said the speed. So what's the speed going to be at 2 seconds? Got it. And this is meters per second, 15.6 when you plug that 2 in. It actually ends up being negative 15.6, but this is a speed, so we're going to take the direction off of it. Alright, last one. I have a ball thrown from a balcony 40 meters above the ground. Assume that after 1 second, the velocity is negative 9.8 meters per second. Determine the ball's initial velocity. Okay. So I'm not giving you everything you need to just find a limit, am I? Not at all. What piece of information is missing that they're asking me to find? If you wanted to write a function here for the height, what part are you missing? Initial velocity, which is exactly what they're telling me to find here, right? So what does this function look like with the information that we have? First of all, is it meters or feet? So that'll be negative 4.9 t squared. Am I throwing this ball up or down? I don't really know, right? Do I? Well, I could throw it up, and by the time it comes down, you know what I mean? By the time it's coming down, it could be that. If I'm throwing something, I'm throwing it up. That's what I think what I'm doing. So we're going to go with plus, and we're going to see what's up. Plus v sub o t, isn't that what my formula looks like? Initial velocity times time. How high does this thing start? So this looks like my function. Everybody doing okay? What else do I know? I know 1 second, and I know the final velocity, which means that's like my final answer, right? Like after I cross things out, plug it back in. Okay. So what can I do now? What can I do with this? Don't you normally plug that in? What do you get when you plug it in? You get 35.1 if you plug it in. Well, maybe I'll do this one. Isn't that what it looks like when you plug it in? So you put together this and this. You got 35.1. But we still have this, don't we? So won't that be 35.1 plus VO? So that goes in here, 35.1 plus VO. And now I think I'm going to set up my limit. And we're going to see what it looks like. The limit as t approaches 1 of h of t minus h of a. All over t minus 1. Anybody have any questions in the setup here? Why did that move? Say it again. It isn't. They aren't going to be able to be combined. But I can combine something. Can't these terms right here be combined? Yes? So I get negative 4.9 t squared. I think I'm going to say plus VOT minus VO, and then what is that, 4.9 all over t minus 1. How many terms we got up there? 4. How do you factor something with 4 terms? Factor by grouping. In order to do that, I want to group things strategically. Did everybody see how this 4.9 and that 4.9 could be factors? So I'm going to put those two things together when I group. So I'm going to rewrite this a little bit. Like that. And then I'm going to group it 2 by 2. Follow me? All right, what can you take out of the first group? How about a negative 4.9? And then I have t squared minus 1 left. So everybody see why it's a minus 1 instead of a plus 1? Okay, what can you take out of the second group? VO, which leaves you with t minus 1. Check it out. It's looking pretty good, isn't it? This is all over t minus 1. Yes? Doesn't the t squared minus 1 factor again? So now I'm here. Now if I want to reduce things, that means I have to take it out of every single term, correct? Yes? Terms are connected by multiplication, right? So this thing right here is all being multiplied together, isn't it? That's one term. These two things are being multiplied together, aren't they? That's one term. And this thing down here is one term all together, right? So if I want to cancel out the t minus 1, there has to be a t minus 1 in every term. Is there? T minus 1, t minus 1, t minus 1. Which means I'm now left with negative 4.9 times t plus 1 plus VO, and it's over nothing. So now am I able to plug in that 1? You betcha. You put a 1 in there. What's 1 plus 1? 2. What's 2 times negative 4.9? What did I know my initial or my velocity was after 1 second? Negative 9.8. Guys, so what's VO? So what does that mean? It was dropped. So it didn't matter if I put a plus or a minus on there. Because it wasn't thrown up or down, it was just dropped, wasn't it? Does that make sense how all that worked out? Okay. So the initial velocity is 0 meters per second. I think there was a part B to this question. We'll go all the way back here. Would the answer to part B be the same if the balcony were higher? What do you think? If the balcony were higher, would it change our answer to part A? It was being dropped, wasn't it? Doesn't matter. Questions? Okay. Homework. You have 4 more problems left on that document on Google Classroom. This is lesson 2.2, days 3 and 4. Combine those together. There should be 4 problems there for you, all application of Google Classroom.